At this point, we've already done a hello world type Verilog implementation. And what I want to do next is talk about how you could connect modules together and reinforce the idea that modules basically are circuits. All right. So one of the words that we're going to use a lot is the word instantiation. So the idea here with instantiation is that we have a part. In this case, we have a part that's called a half adder. And later in the course, we're going to learn what this half adder does. But for now, you just think of it as a circuit. And this is literally a circuit. It's an AND gate, an exclusive OR gate that has inputs A and B and outputs sum and carry. So it's one part, but we can make more than one copy of it within a given design. So that's the idea. You build up modules. This is the description of a half adder module. In fact, you know enough to understand how this would work. We have inputs. The inputs are A and B. We have output wires that are sum and carry. So we define that in the ports of the module. All right, so here's this block. You can think of it as a circuit or a module. It's got inputs A and B, outputs sum and carry. So we define those. And then we assign the outputs according to the logic conditions that are in this circuit. It's a very simple circuit. So there we have it completely described. Okay, so the next thing I want to do is talk about how you could build up a larger circuit from a half adder. Okay, so the larger circuit we're going to build is a full adder. Okay, and this is the schematic diagram. Here is the half adder circuit. We still have the exclusive OR and the AND gate that are inside the box. We no longer can look inside the box. It's covered up. It's part of the description of the module. And here's a second instantiation of that half adder circuit. So it's the same circuit, but it's a copy of it that's laid out within a larger circuit. So this graphically shows that we have two instantiations of the half adder module. All right, so what I'd like you to be able to do is to write the Verilog code that does the instantiation. Okay, so let's go through that. The first thing we need to do is we need to define the ports of the full adder, and you can look at the external parts of this schematic. We can see there's still an input A, an input B. We now have a new input called Cin, and then the output side we have sum and Cout. All right, so those are defined as the ports. They're just listed here: input wire A, input wire B, input wire Cin, output wire sum, output wire Cout. We have all the ports defined in the module. Okay, the next thing we notice is that the purple part, the purple thing in the schematic, these are internal wires that the circuit would need to connect everything together. So we declare those wire S1, C1, and C2. So you see these are labeled here. From there, the next step is to instantiate modules that we've already written. So we already have a module called half adder, and so you put the module name, and then you need an instance name. Okay, because we have more than one copy of the circuit, it's important for the hardware description to be able to distinguish which version of this circuit are we talking about. So we have a label HA0, I show that here, and we have another label HA1. That's the instance name. The next thing we need to do is to connect the modules within the schematic. And we can do that by a naming convention. And let's talk about how to do that. So we click on this. You can go to this graphic and you can click on it and see what happens. When I click on it, it says, okay, I'm going to have the input to the half adder that I'm instantiating, dot A, is connected to A. All right, I just happen to use the same name. Dot A is connected to A. All right, so then over here, dot B, the input here, dot B is connected to B. All right, it gets a little more interesting when I look at the sum bit. Okay, so the sum coming out, that's an output. So dot sum on half adder HA0 is connected to wire S1. All right, so dot sum S1, that's the naming convention. Okay, so you can start to generalize this. Dot carry, the output carry, you can see that's connected to wire C1. All right. So that does it. That totally instantiates HA0 because we've connected all the inputs and we've connected all the outputs. Let's do the same thing for HA1. So the steps are write down half adder, that's the name of the module, write down the instance name, HA1. Dot A, the input dot A, gets connected to wire S1, okay? And then dot B, all right, the input B gets connected to wire CN, and continuing on, dot sum, the output dot sum gets connected to the output here on the circuit called sum, and dot carry gets connected to wire C2. Okay, so that connects the two modules together, but then we also had some external circuitry in this design where we had an OR gate that gives you Cout, and we can just assign that with a logical condition. So Cout is C1 ORed with C2. The vertical bar here indicates OR in Verilog. All right, so then we end that with an end module, and that fully describes the full adder, okay? And so once you have that, you could test it. I'm going to leave off the test bench, but you can see we have some code here that's going to run and test this. So I'm not showing the test bench code, but basically what you could do is you would just go through all the input combinations of A, B, and C, and you can run that, and you can see the different signals taking effect throughout the circuit and look at the outputs there. And so the reason I like to show this step is I want you to think of this. Here's a couple of modules. We only had one module description for half adder, but we were able to use multiple copies of it to build something called a full adder. Okay, so play around with that. Instantiation is important. We're going to talk about how to do that for lots of different circuits within this course.